Alright guys, sorry I couldn't be there today, but we are going into chords today. So I just want to walk through this lesson with you guys a little bit, go through the theorems that are involved, and then let you guys kind of follow along with the work, and then hopefully you guys can kind of work on your own from there. So, alright, so this first part. The first theorem we have is that within a circle, or congruent circles, the congruent central angles have congruent arcs. So these angles right here are considered central angles. They're angles formed at the center of a circle. So if these two angles are central and they're equal, then these two arcs are also equal. They're called intercepted arcs because the two chords here that reach out to the circle are intersecting in these two arcs. Kind of like you take out the slice of pizza, the crust of the pizza is considered the intercepted arc. So if the central angles are congruent, then the intercepted arcs are the same. And then this opposite's true. These two chords are equal, the central angles are the same. So essentially, if it takes you 30 degrees to get from here to here, it takes you 30 degrees to get from B to A. So the measures are going to be the same. The second one is within a circle, congruent circle, same thing, right? Congruent central angles have congruent chords. So these two angles are going to form these congruent chords right here. So the distance from B to A, whether it's a straight line or curved, is going to be the same as C to D, whether straight or curved. So if the central angles are congruent, these two arcs are equal, and the two chords are equal. And then the opposite is true. If the chords are equal, the angles are equal, the arcs are equal, so they're all related to one another. The third one down is within a circle, same thing, congruent circle. Congruent chords have congruent arcs. So if these two chords are congruent, if these two points, C and D, and AB are the same distance apart from one another, then these two arcs are going to be the same. It should make sense. The distance around the circle, if it's the same, then these 2 points in a straight line are the same distance away. So if the two arcs are congruent, the two chords are congruent. And the way you write an arc is with AB, we normally put a line over the top. Here we're putting a little, little curved hat on the top of it. So it's a part of the circle going around, like arc BC right there. And then the last two here within a circle, congruent circle. So if these two chords are congruent, okay, that means that they are the same distance away from the center. If I get closer to the center, my chord has to grow to reach both sides of the circle. So the closer I get to the center, the bigger. The further away I get from the center, the smaller this chord is going to be. Okay, so if they are the same distance away, if these two line segments are equal, perpendicular here, then what happens is these two chords are going to be congruent to one another. And then the last one is just that if you take a diameter and you draw it perpendicular to a chord, it cuts that chord in half. And then the opposite's true. If I cut the diameter cuts the chord in half, it's also perpendicular. And what happens a lot with these questions is you're going to be looking to connect a line segment here to make a right triangle and find some missing pieces. So if you see the diameter drawn through, so it's perpendicular, it bisects the chord in half, and vice versa. If it shows you that these are both like 7, then you know this is perpendicular, and you're going to be looking to set up a right triangle. And we'll get to a couple of those in a little bit. All right, so the first question on the next page, they want to know what the value of x is. So for number 3a, we can see that these two pieces are congruent. So, which means this whole entire arc here is 36. So if this is 36 and it's congruent to this, then we know that these two arcs are congruent, and we know that x is going to be equal to 60. Okay. For letter B here, that's it. On the next page, you can see that these two are equal to each other. So this is 3 and this is 3, which means that these two chords are the same. Now what we know is that this segment right here is 8, and it's congruent to this one. So that means that this segment down here has to be double that. Okay? And the next part, we see that these two chords are congruent, once again, perpendicular. So this is 4.9, so is this. We know that this is actually 6.3. So if we double that length, that's what x is going to be, and it's going to be 12.6. Okay, so the first two parts, not too difficult. Here we're getting into the part where we have this right triangle, right? And keep in mind, this little piece is actually part of a diameter that stretches through the circle. So what happens if it's drawn perpendicular to this chord? You guys remember that last theorem we talked about? It cuts it in half. So we know that these two parts are now 7. Now, keep in mind that I'm getting now this right triangle forming here, okay? And this line right here represents the radius of the circle. Well, we want to put that back, okay? So, if the whole thing was 18 right here, then this piece is just 9, and now we can go to work with the Pythagorean theorem. So we do a squared plus b squared equals c squared, so 7 squared. We do that c squared minus a squared. So 7 squared, or sorry, 9 squared because it's the hypotenuse here, okay? Minus 7 squared, the leg has to equal the leg squared. So that's 81 minus 49, which is 32. And we can break that down, so that's 5 2's to get you 32. You take out 2 sets, and we end up 4 radical 2. Just a little review here. We didn't have to do this, but it's kind of going through this because it will pop up here and then. All right. This next question, same thing's going on here, right? So I got this little piece here, which is forming this diameter. It's cutting this in half. So really, if we want to figure out x, right? If I want to know what x is, what I actually need to know is which one of these parts right here? What's this segment right there? So if we focus in on this right triangle again, okay, and we do our c squared minus a squared is equal to, we'll call this y. We already have an x, so we don't want to use x again, we use a y squared. And so we do the work, 225 minus 64 is equal to y squared. And if you subtract them, you're getting 161. And so that means y is the square root of 161. And if you bust out your calculator here, you can. Remember that it's going to be menu 23. So calculator page, menu 23. Type in 161, you'll see that that is actually a that is not factorable. There's no perfect square factors of 161. So this piece is just the square root of 161. So if I have 2 of them, then it's just 2 times radical 161. That's what this whole entire thing is. Okay? And that's your answer. All right, let's open this next question. Next question is a little bit same concept, just a little bit different. So I'm looking to find the measure of this piece right here. Okay? Now keep in mind, we have this line segment cutting through, and it's perpendicular. We know it's going to cut this segment in half. Okay? What we really want to do is we want to use a right triangle to figure out the radius. Now we know there's no right triangle going on here with this, but can we redraw a right triangle? Can we draw a line segment that connects to form a right triangle? And the thing about doing this is this piece right here, by drawing this line in to form this right triangle, we've now actually just provided another radius, right? So x being the radius, that means this is also x. So all we have to do now is use the fact that this is a right triangle, and we can get this done. Remember, if this is drawn perpendicular, this is cutting this in half. So this is 4.2 squared plus 5 squared is equal to x squared, right? Diameter cuts the chord in half. If perpendicular means it bisects it, and this is 10, so the whole thing, this part's 5. So 4.2 squared plus 5 squared is x squared. This doesn't come out nice, but it's 17.64, 25. You get 42.64. We take the square root, and this one you can just leave in that form. The students last year when we did this, we ended up with this decimal 6.53, but you don't have to worry about that. You can just leave it. I would leave it as that radical right there. Okay. This number 4 question, just if NO is 12 and PQ is 8, how long is the radius in yours 1/10 of an inch? It's just these are cutting each other in half essentially. So when you draw on the diagonal here, this is bisecting itself. So these two line segments are bisecting. So this is just going to be 4 and 6, and you're just going to do Pythagorean theorem. I don't have any work for that one, so I'm not going to get into this one. Same thing here, you can do this. If this is drawn perpendicular, this is just half, so it's 7, 3, and R, and you can just do Pythagorean theorem here. I'll let you guys do that one. I didn't have any work for that one yet either. I did want to go through it though so you see it. And you can see on B here, once again, we have the diameter drawn, or the radius drawn in. So you can, for this is 15 for the radius, so is this. And then you can just do Pythagorean theorem here with the 15, the 11, and the y. Okay? just walking through. Give those a shot for some extra practice. On to the next page for number 6. So here we're talking about our central angles here being formed. So once again, the central angle is formed at the center of the circle. Okay, so we have 3x plus 5, x minus 1, 60, and this is the diameter. It really should be given to you as a diameter, but I'm letting you know it is. So if this is 60, we know that this cuts the circle in half, so these two together should make 180, which means that this is going to be 120 degrees right here. And then we can just set up an equation where we add this plus this plus this plus this together, and we're going to get 180 degrees. Really, you can do 360 for all of them. So I'm going to walk back through that. Since these two are 180, we know that these two have to add to 180, and we can just make that here. Or you can add all of these together to get 360. And you can do that. So I'll let you guys finish this one off for number 6. Okay. 6 is 4x, so 44 I think you're coming up with there for x, if I'm doing that one right. Okay, on to part B. So for number B, nice. What we're doing here is we're trying to find x. And so a few things you're going to notice. Number 1, please remember what we talked about before. If this arc is 70 degrees, okay, this is the same as, so this arc, because this is 360 degrees go around the circle, this is 360 degrees around the circle, we know that this angle is going to be the same as this arc, so this is also 70 degrees, okay? If you focus in on what's going on here, we have this triangle, we have a 70-degree angle, and these two segments are both the radii of the circle, so they have to be equal. That means that these two angles are going to be equal, and we can just set up an equation when we do x plus 70 is equal to 180, and we can go to work. You should end up with, I believe, 55 for this one, so if you go through and do that one. And then for number 7, we move into a glorious proof involving some circles. Look at this. Just when you guys thought you were out, they grab you and pull you back in, right? So what do we notice? We got a circle. We know that AB, this arc here, is equal to AC, or sorry, we're given that this line AB is equal to AC. We want to prove that angle ACO and ABO are equal. Now, how are we going to do that? Well, first of all, we're going to bust out a T-chart, statements and reasons, and we're going to focus on the fact that if we want to show that these two angles are equal, we're going to have to get the true triangles congruent and do CPCTC. So remember, first step, givens, okay? Next thing you're going to do, look for anything here going on that's going to be the same. We know that these two triangles share that line AO, so that's reflexive, okay? We also know in the given that these two segments are equal, so we have those equal. And now we're going to get added on that, like these two lines. What do they represent in the circle, right? These two lines are the radii of the circle, so we know that OC and OB are going to be equal. We have the triangles congruent by side, side, side. And then we can finish off with CPCTC. All right. The last question we're going to do here today, find the measure of arc AB, so minor arc AB. Now, a minor arc, okay, is an arc that is less than 180 degrees, okay? So you can see when we talk about arc AB, I could either travel this short distance around the circle, that's a minor arc, or I can travel all the way around here the longer distance, which is definitely more than 180 degrees. This is called a major arc, okay? So we want to know the measure of this arc right here. Now, how are we going to do that? Well, remember, this arc is equal to the central angle here, right? So if I don't think we went any further. That was it. So let's do this one together here. So if I can figure out the measure of this angle right here, then I can get the measure of, I'll know that if I connect O to B, this angle is going to be the same thing. And then once we have the measure of the angles, we can make this happen over here. Okay? So in a right triangle, right, once again, if this is perpendicular and this is 30, that tells us that this is going to be, let's shrink this down a little bit, that this segment right here is going to be 15. Okay. All right, so this is 15, which means that this guy over here is 15, and then we can just do some SOHCAHTOA. So if we're looking for the measure of the angle, this is once again a right angle. So we're going opposite and hypotenuse. So we would do sine of my angle, okay, we'll call it x, is equal to the opposite, which is 15 over 17. And then what we're going to want to do here is bust out the sine inverse, right? So the sine inverse of sine of x is equal to the sine inverse of this guy. Okay? So if you type 15 over 17, and you get the sine inverse. So sine inverse 15 over 17. We get 61.92 degrees here. Okay? So x is going to be equal to 61.92751,306 degrees. So that means the measure of angle AOB, right? The measure angle AOB is equal to 2 times that. So if we double that, we're going to get 123.8550261. Okay? And that is also the measure of the arc. So arc AB, and when we do our arc, we're going to put a little hat on it, so it looks a little something like this. Little hat. That's a pretty bad hat. Sorry guys. Let's try that again. Little hat on it. You know, if you liked it, then you should have put a hat on it, right? And that is equal to 123.8550261. Remember, it didn't say with the round to, so we're writing out that whole number. So this central angle here is equal to the measure of the arc. So once we get the measure of this angle, we just double it, and we're going to get that. Okay, guys, your homework tonight is on page 4, where it says homework. You're just going to go through and figure out these guys right here. Okay? Little proof there for you guys. Just use your parts of the circle to help you out, and you should be good to go. Any other questions, let me know, and I will see you guys on Friday.